Hi everyone, I welcome you to this learning activity. And in this learning activity, we are going to perform accuracy assessment. So let's head over to Earth Engine to unpack. So once you bring your Earth Engine up, so in this activity, we're going to build on what we covered off in the last activity where we created classification images using random forest and also the classification and regression tree algorithms. So when you go to your layer manager, you are going to see your random forest classification map, which is this one you see here. And you may also, this is the classification and regression tree imagery. And you also, the next one is going to be your random forest classification map. Okay, so what we did is that we compare the classified images and then the original data just to visually assess the quality of the classifiers. Okay, but in this session, we are going to assess the performance of these models quantitatively. And so to do that, if this is your image, you remember that we collected some samples, and these were the samples we used to train our models, and then we use that to actually create our classification image. Okay, so one of the things you can easily do is that you can partition this data and use part of it for the model training, so to train the random forest algorithm, and then half of it to use to actually test the performance of the random forest or any classifier you used. So what we're going to do is that we're going to select another set of samples, and then we are going to use that to test or to validate the classifiers. Okay. So just to flag that the process that we are going to go through for the model validation is reported in this study here. So the practices that have been recommended to validate land cover classification maps is in this study, and we are going to follow that. Okay, so when you go back to code editor, one of the things the study recommended is that you have to stratify the image, that's the original image. So now that we know the different surface types or the land cover types we have in the image, again, like we did for training of the model where we sample site with these ones, we are now going to ask the computer to select 10 samples from each cover type. So we have 4 different cover types, and so we're going to ask the computer just to do that for us. So here we're going to ask the computer to randomly select points that will go out to the field and investigate that they are this cover type and not that cover type. So just to remove bias out of it, we ask the computer to do that for us. So we're going to call the stratified random sample, and this is the method to do that. And this one is saying that for every cover type, select 10 pixels. So if you have got 4 cover types or 4 classes, you're going to have what, 40 selected. And then we're going to use our region of interest, which is our study area or the project area. And then the scale of the Sentinel-2 image we are using is 20. And then we set a random seed. And in this case, I use 000. You can use any number at all. And then we want to see the point. So that is why geometry is here. We set it to be true. So once you run this, and then the next thing is that we want to visualize that. Okay. So once you run it and visualize it, so once you run everything, so for example, if you run from here, you run the code here up to this point, what it's going to do is that it's going to generate another set of points that we are going to use for our validation. Okay, so this is the one that we use to train the data, these red ones, and it's going to generate another one that we're going to use for the validation. Okay, so once you run that, you may see the points. So in your layer manager, you may see the point as was random stratified points. So this is the one that the computer has given to us, and we've distinguished it from the training one. So the training data, the one we used to teach the model and created the classification map, those are the points in red. And the new points for validation, potentially for validation, they are in the yellow. So what you have done here, it means that now you'll be going to the field to inspect all of these points, okay, and to see which one is water, which one is vegetation, which one is agriculture, and then which one is maybe built up or developed area. So these yellow points, you're going back to the field again to actually inspect them, okay. So that is what you're going to do in real life, okay. But one challenge is that you can see that some of these are actually overlapping with your training. So you could see that some of the points are almost very close to your training point. So this and that may be close. So ideally, you want the yellow point to be far away from the red point, so that there wouldn't be any confusion. That can sort of affect the performance of the model. It can give us highly optimistic model. So if you want this yellow point, which is potentially going to be your validation point, to be independent of the red, and one of the things you can do is that you can collect your own points. When you go to the yellow point, and this one, for example, that is close to the red, the two yellow points close to the red, what you may want to do is that you may want to disregard them. Even though the computer has flagged that you can select it, you may not collect it because maybe they are too close and they are similar. So you can have a distance threshold to say that I want to take only the points that are maybe 10 kilometers or maybe 1 kilometer away from the red point, the training areas, so that there will be spatial independence between the points that were used to train the model and those that were used to actually validate the model. Okay, so in this challenge, one of the things you may want to do is that you may want to manually collect these samples, the testing samples, to ensure that they don't have any spatial relationship with the red ones. Okay, you want to collect the yellow ones that they have no spatial relationship with the red ones, so that you have a more robust, accuracy assessment. So in this next line of script here, what we have done is that we have manually, and this has been given to you, we have manually selected some of these yellow ones that are quite far from the red ones, and those ones that are not, you have just discarded them, and then you add to it to give you a complete set. So what you may want to do here is that, for example, if you go to the field and you think that, well, this and that, they are really far apart, then this one satisfy the condition. So then you go to here and then drop a pin here. So this is you with your GPS on your back, and you say, well, I'm going to take this site, and then you're going to go here and then feature collection label, and then you give this one maybe 0, then you put water here, water _v. V is to say that there's another label called water, but that is for training the model or teaching the model, but this one is for validating, to test the model. So we put V there to distinguish it. So once you are happy with this, and this is a feature collection, you click OK, and then you go again. So you sample, and again you take the hand button and you say, okay, maybe you're happy with the distance between this one and that one. So you're going to select this one, and then you are going to disregard this because it's also close to that. So you are going to keep maybe this one here and that one, or you may just disregard everything because they are both close to the training set here. And so maybe in this case you would select this one here because this one is quite far from this and that, and also from this. So you go and take your point again here and then select this, and then you go to point for water, and then you do the same thing for the other surface type. So this and that, they are really vegetation sites. You can see that the distance is quite okay. So you can say, okay, they are not close to each other. So again, you go to new layer, and then you take this one, and then you're going to select this one. This one you agree with the pixel the computer has selected because it's quite far from the training site. And then here you go here, and then again, feature collection, property, label, and I don't know the value, but you may call it 1, but I know the name definitely is vegetation, so you may call it vegetation, and then you put V here, then you click OK. So you do that for the whole study or for the whole point, and even you bring it in your own point. So for example, if you collect samples for water and you feel like, oh, the samples for water is not enough, you can manually add to it, even though there's no selected pixel here by the computer. You can just go to water and then click here, for example, and then select your own because you think it's a good place because it's quite far from the training set. So you know that, well, you can put a point here and then you call it water. Okay, so you can keep the yellow ones flagged by the computer if they satisfy the distance condition. If they don't, you can manually add to this. And by doing that, you are creating your validation set. So in this activity, all of this thing has been given to you. So if you look at, if you scroll down and you go to here, you can see that the points to use for the model calibration, or sorry, the model validation has been given to you. Okay, so that is what we are going to use, and that is how you collect it. Okay, so once you have created your samples, your validation samples for each cover, like we created for water and then NTV and say CTV. So this is it here. So you can merge them. You can merge the cover types, so the samples. So once you merge them, remember we have covered this in the last activity because we did something similar for collecting samples for the model training. We have done that already. So this is sort of repetition of what has been covered in the previous video. So you have to merge the features together and to have one feature collection. And then when, for example, you print to the console, you want to see how many samples you've collected in total, for the model validation. And you go to your console to see the number of validation points to see that, so you can number of validation points. Where's that one? This one here. So the number of validation points, yeah, that's it. So you got 59. So that is it. So it means that you have 59 points that you are going to use to test the model, to quantitatively assess the performance of the classification models. Okay, so that is what you have here. Okay. Well, so the next thing to do is that you are going to use this validation set. So we created a variable called validation point, and then we're using that to apply to the original Sentinel-2 imagery. And so once you have done that, you're going to use the error matrix, and then we're going to compare what we observed on the field, which we call label, and then what the model classified. Okay, so we're going to compare what we observed on the field and then what the model predicted. Okay, and so when you print that to the console, you are going to get in the console, you may see a layer called error matrix. So that is the error matrix. So when you, this is it here. So when you run this, you're going to see it as error matrix. So you're going to see this here. When you click on the expander here, you see that this is what we have here. So this is the number of pixels for each cover type. So you go column by column by column, and then you go row. So that is what you have here. So the number of pixels in this column, the number of pixels in that column, and also the number of pixels across, the number of pixels for class 1. What is class 1 or land cover type 1? The number of pixels for it along the table. So this is what we call the error matrix. And then you are going to see that you are going to create a table using this numbers, using this sample. Okay, so you are going to create a table using this sample, and I'm going to show you that in a PowerPoint where we have brought these numbers into a table in a PowerPoint, and then I'm going to talk you through there. Okay.